All right, guys, we are gonna keep on moving throughout this chapter. Our next two lessons are going to be about areas of regular polygons. And so a couple of just vocab things to remember from first try is that if a polygon is a regular polygon, that means that all sides and all angles are congruent. Okay, and so when we're talking about the different parts of a regular polygon, if all of the sides are congruent, that means we can kind of draw this little circle around it. And so the circle is touching each of the vertices. And so when we take the segment from the center of that polygon out to each vertice, that creates a radius of the circle that is kind of outlining our polygon. And all radii in circles are congruent. And so what that does is that takes all of these segments and it makes them congruent. And so we have now a bunch of isosceles triangles in our polygon. Okay, so the radius of a regular polygon is the distance from the center to the vertices. And remember, they're all going to be congruent. So this new word that is used to find the area of a regular polygon is called the apothem. All right, and so the apothem is this segment right here. So you still are starting at the center, but you're not going to the vertice. You're going halfway between two consecutive vertices. Okay, so it'd be the perpendicular distance from the center to the side. And so the apothem is helpful because it bisects both this central angle right here and the opposite side. And so what that means is that that angle is going to be congruent to that angle. We know that this is going to be a right angle, and so that's going to make this also a right angle. And so we've got these two smaller congruent triangles because these two sides are also going to be congruent. Okay. And so that's going to help us when finding the missing parts to help us find the area. So a couple of regular polygons that you're going to make sure you're going to want to know. I'm going to highlight some of the ones that you'll see the most. But that doesn't mean that you'll never see the other ones that I don't highlight. We're just going to practice more of the more common ones, I would say. So a triangle has three sides, right? They'd all be congruent. A square is a regular quadrilateral because it has four congruent sides. A pentagon has 5. A hexagon has 6. Heptagon has 7, 8, 9, 10, and then anything past 10 doesn't have a special name to it. It's just the number of sides gone. So a 21 gon is a polygon that has 21 sides. An n-gon is a polygon with n sides. So you can say that for like a 15 gon, 16 gon, etc. All right, so before we get to the area part, I want to work through how we figure out the angles within our polygon. And so first you need to figure out how many sides you're working with. So if I start here, I always kind of mark the side that I start with. So 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon, which means it has 8 sides. Okay, so then remember from first trimester, the way that you can figure out the measure of each exterior angle is by taking the 360, the total degrees in a circle, and dividing it by that number. And the exterior angle is going to be the same as all of these. These are called central angles. because they're in the center of your polygon. So to figure out the measure of each central angle, you're always going to take 360, right? And you can kind of see this little circle that I've drawn in here. And if all of these little angles are congruent, because it's a regular octagon, that means we can just divide by 8. So each central angle is going to be 45 degrees. And so that would be the measure of angle 1. So now angle 2 is this angle right here. Well, this segment right here is the apothem of this octagon, and the apothem bisects the vertex of that central angle. And so if this whole angle is 45 degrees, if I divide that in 2, I get 22.5 degrees. And then to figure out this kind of corner angle right here, we would use this triangle. So if we know, again, this angle is also going to be 90 degrees. So if we take 180, the total degrees in that triangle, subtract 90, and then the 22.5 that we just found, we are going to get 67.5 degrees. Okay. And so that is going to be helpful when we're trying to figure out the angle measures to help us find the area. So the area of a regular polygon is 1/2 times the apothem times the perimeter of your figure. Okay. So there may be some background work that you need to do. Now keep in mind that there are a couple of regular polygons up here that we have much simpler formulas for. So you want to keep those in mind too. Just because you see a triangle or a square does not mean you have to use this formula. It's actually probably going to be more work. So you want to keep in mind that the area of a triangle is 1/2 base times height, and that the area of a square is base times height. Again, that's going to be much simpler than using this, but obviously you can't do that for octagons, hexagons, pentagons, etc. Okay. All right, so let's just start with this first example right here. All right, so this says find the area of the regular decagon. So that means 10 sides. Oh, I just realized that. Now, when you're finding the areas without the apothem, we're probably going to focus mainly on triangles, squares, pentagons, hexagons, and octagons. Those are just the ones that are honestly a little bit easier. And again, in this kind of situation, I'm not trying to fool you with anything. I'm trying to keep it, challenge you guys a little bit, but also keep it fair, you know what I mean? All right, and so in this one, we're looking at a decagon, but we're given everything we need to know. And so there's not a lot of background work that you need to do. So the formula for area is 1/2 times the apothem times the perimeter. So if I just substitute in what I know, the apothem is 12.3 inches. And I know that the side length is 8, so that means the perimeter is going to be that side length times the number of sides. So that's going to be 80. So that's really the only background work that you need to do, find the perimeter. So when I multiply these all together, you're going to get 49.2. And then we're still looking at units squared because we're finding area. So this is going to be inches squared. Okay. All right, so now let's look at what happens when you're not given the apothem. And so what we're going to do is start by figuring out what kind of figure we're looking at. It's important to know that's regular. And then we need to figure out the measure of the angles that we're working with here. All right, so this has 1, 2, 3, 4, 5, 6 sides. This is a hexagon. All right, so I'm gonna go ahead and I'm gonna draw in my center. And you always wanna start, and you can go to any 2 consecutive vertices. I usually go to the bottom 2. And then I'm gonna draw in my apothem, right? That's what this is right here. Because in my formula for area, it's 1/2 times the apothem times the perimeter. Well, I don't know the exact perimeter right now, but I do know that the side length is 8. So if I just substitute that in, 8 times 6 is 48. So now I have to find the height of this, which is the apothem. Okay, all right, so I'm gonna start by figuring out what the measure of this entire angle is. Then I can cut that in half to figure out this right here. So if I take 360 divided by the 6 central angles that are formed, I get 6. Not 60. I knew the answer and I got it. So 360 by 6 is 60. All right, so this whole angle then is 30 degrees, or 60 degrees. Oh, sorry, I'm getting ahead of myself here. So now I'm gonna divide that in half because I know that this angle is being bisected. So this angle right here is 30 degrees. Well, that's good because what that does, I'm going to draw this out separately over here. That created a 30, 60, 90 triangle. And so this right here, that long leg across from the 60-degree angle, that's going to be my apothem. And so I know that this whole side is 8. And so again, that other property of the apothem is that it bisects the side that it's across from. So that means this is going to be 4. And then when I multiply that by radical 3, I am going to get my apothem. We don't really need to know the hypotenuse. That's just not really necessary in this particular problem. And so now I can come back here. I'm going to actually erase this up a little bit. So area is 1/2 times the apothem times the perimeter. Well, we just said that our apothem was 4 radical 3. And our perimeter was 48. And so now remember, when we're multiplying with these radicals, you multiply all of the non-radical numbers together, and then we'll just tack that radical on at the end. So 1/2 times 4 times 48 is 96. And so the area of this hexagon is going to be 96 radical 3 meters squared. All right, and so now in number 4, we are looking at a triangle. We're given that these are all regular polygons, so that tells us right away that this is going to be 10 meters and this is going to be 10 meters. So we could use this formula, right, and kind of draw in these little triangles down here, but that's going to be a little bit more work. So we're going to use the simpler formula, which is the formula for any triangle, whether it's a regular triangle or not. And so if I substitute in what I know the base is 10 meters. I just need to know the height. Well, again, special right triangles are going to help us out here, because if I know that this is a regular triangle, that means that each angle is 60 degrees. And so then if I just use this little piece right here, I've created a 30, 60, 90 triangle. Well, this height still bisects the side, so that means that this is going to be 5 meters, and that would be my short leg, and so the long leg, which is going to be the height, is 5 radical 3. And then we'll still multiply the parts together. So half of 10 is 5. 5 times 5 is 25. So the area is going to be 25 radical 3 meters squared. And now this last one, let me just check something really quick. I can't remember, this didn't print very well. Let me see if that was originally going all the way up. It didn't print very well there. There we go. Okay, well, I'll just make this up. And so now this last one we're looking at is a square. So again, the much easier formula to use is just going to be base times the height. Well, because we know that all these sides are congruent, I'm going to pretend that this is the whole diagonal. This is a right angle. And so if we are trying to figure out the base, which is going to be the same as the height here, I need to figure out what these side lengths are. Well, one of the properties of a square is that the diagonal bisects the angle. And again, because these two sides are congruent, that means that these two angles have to be congruent. That's a property of isosceles triangles. And so now I've created a 45, 45, 90 triangle. And so remember, we have to figure out the relationship between, we haven't really done a ton of review with 45, 45, 90, just because those are usually the easier ones. So remember that the legs are always the same. And then the hypotenuse is always radical 2 times the leg. And so if your hypotenuse is a whole number and not something with the radical 2 on it, you have to divide that by 2 and then multiply it by that, which is essentially dividing by radical 2. So that means that both of these sides are going to be 10 radical 2. Okay. And so when I go and I multiply those together, base times height. So we'll take the outside numbers and multiply them together. So 10 times 10 is 100. Radical 2 times radical 2 is radical 4. Well, the square root of 4 is 2. That can be simplified, unlike the square root of 3. And so this is going to be 200 millimeters squared. Now, because we can use special right triangles for all of these, it's important that your answers are all exact, meaning simplified radicals, no estimating, anything like that. So tomorrow what we'll look at is when you can't use special right triangles, then we'll have to go back and use trig to answer, but the process is going to be the same, okay? So as always, just hop on Canvas conferences or message me via Canvas or Remind if you guys have any questions. Bye, guys.